Okay, these are from section 2.1 in the AP Calculus textbook. We want to write the equation of the tangent line that goes through this point. To write the equation of a line, we need a point, which we have, the xy, but I also need the slope. The slope is going to be the derivative at whatever x value they give me. So I'm going to use my rules and find the derivative of these. The derivative of y equals x is 1. Well, before I even do that, let's rewrite this thing. I'm going to call it y equals x plus 4x to the negative 1. Then I'll take its derivative. The derivative of x is 1. Keep the 4 out front. Power base, 1 less power. So I end up with this for my derivative. I need to know the derivative when x is negative 4. So that's what f prime of x would equal. I need to find f prime of negative 4. So I'm going to replace in a negative 4. I believe this is squared on the bottom. So you have 1 minus 4/16. I believe that's 1 minus 1/4, right? 4/16. So I think that makes the slope 3/4. My formula is y minus the y value is equal to m times x minus the x value. This will give me the equation of the tangent line. The y value is negative 5, the x value is negative 4, and we just found the slope to be 3/4. If I was to distribute the 3/4 times x, would give me 3/4 x. Two negatives make it a positive. 3/4 times 4 makes it a 3. And if I subtract 5, I end up with y equaling 3/4 x minus 2. Then they want us to check it with the graphing utility on using your calculator. Hopefully this is correct. Okay, this one we want to have the equation of the tangent line that is parallel to this other line. If I was to simply subtract x, and I knew that this was mx plus b, can you tell me that the slope is negative 1? So if the slope is negative 1, and I was to take my derivative over here, which would be called f prime of x, you keep the negative 1/4 out as a constant, power base, 1 less power, 2/4 is 1/2, so you get negative 1/2 x, right? Negative 1/2 x. What x value? Well, this is the slope, right? So I need to make the slope equal the slope. Why? Because they're parallel. Parallel lines have the same slope. If I multiplied by negative 2, what's x going to equal? Positive 2. If you put 2 in, what do you get out for y? 2 squared is 4 times negative 1/4. I think would give me a point here, and I know my slope. So y minus the y value is equal to m times x minus the x value. This is how we write equations of lines. The y value is negative 1. The x value is 2. The slope is negative 1. So I get y plus 1 equals negative x plus 2. If I subtract 1, I get y equals negative x plus 1. That would be the equation of the tangent line to f of x that was parallel to the line that was given. Okay, after 33, we're going to 35. If I just simply add the y over, what's y going to equal? 3x plus 1, mx plus b. The slope is 3. So I want to find the derivative. The derivative would be power base 1 less power. That is also the slope. So I want the slope to equal the slope because we're talking about parallel lines. Parallel lines have the same slope. So if you were to solve this, you'd get positive 1 and negative 1 as your x values. If you put in a 1 and you cube it, what do you get out for y? With a slope of 3. If you put a negative 1 in and cube it, you get a negative 1 out, also with a slope of 3. So y minus the y value is equal to m times x minus the x value. So that's 3x minus 3. And when you add 1, you get 3x minus 2. Now that's the answer they have in the book. What would you have on this other one? What if you did y minus the y value equals m times x minus the x value? You'd have y plus 1 equals 3x. Would that be plus 3? If you subtract 1, what do you get? The same answer. No, this one's plus 2, right? So I didn't think they'd be the same because what we're talking about is x cubed, and here you have a slope of 3, and here you have a slope of 3. Yes, they'd be parallel, but they're not going to have the same y-intercepts, right? Okay, after 35, I was asked 39. I hope everybody watches it because I'm going to graph the derivative from the perspective of slope. And if you don't mind, I'll graph this one in a different color like a blue or something. So, how about red? Red stands out. Okay, do you agree over here the slope is approaching 0 or horizontal? It's not quite, but it's close to 0, right? But over here, what is it, positive or negative? So I want it very close right here, close to 0. Here is negative, so I have to have a more negative y value. Here it's even more negative slope, so I have to have a more negative y value. What is the slope approaching over here? Vertical, which is an undefined slope. So the derivative is going to look like this. How about over here? Are they positive slopes or negative? Over here they are positive. So I want to graph it positive. Initially it's very positive. Here it's less positive. Here it's less positive. Here it's closer to 0. So I believe the graph of the derivative would look like this. Now let me re-emphasize my original. My original's in purple here. That's the y equals f of x. The one in red is y equals f prime of x. These are difficult. I always use the sine and the cosine. You'll notice on the board there's a formula that says d dx, which means the derivative with respect to x, of sine is cosine. Now what does sine look like? There's sine of x, right? If I look at the values of the slopes, please watch. I didn't really get that one very good, so let's make this a little further. Okay, what is the value of the slope here? 0, so I graph a 0. What's the value of the slope here? 1, so I graph a 1. What's the value of the slope here? 0, so I graph a 0. Here the slope's negative 1, so I graph a negative 1. You'll notice it looks like this. Here the slope is 0, so it goes through 0. Here the slope is 1, so it goes through 1. You'll notice that I just graphed which curve? The cosine. Why? Because the derivative of sine is cosine. And I just did it from the general slopes. Okay, I was also asked, that one was not 39, that was just an example showing that the derivative sign was cosine. Here is the alternate form of the derivative. They want us to do the limit as x approaches c of f of x minus f of c all over x minus c. So this is the limit as x approaches c. I have to fill in what is c. Negative 2. Do you agree with that? What was my original function that was given? X to the third plus 2x squared plus 1, right? Now, if c is negative 2, how do you find f of negative 2? You plug in negative 2. So that's negative 8 plus 8 plus 1. I think f of negative 2 is going to equal just a 1 here, right? So 1 minus 1 is 0, leaving me x to the third plus 2x squared all over x plus 2. Factor out an x squared, and you might notice that x plus 2 will cancel with x plus 2, leaving me simply x squared. And if I'm doing the limit as x approaches negative 2, I end up with negative 2 quantity squared, which would give me the result to be 4. So what we really found was f prime of negative 2 was 4. Now, can we check it? I hope so, now that we know our derivative rules. Let's do the derivative. Power, base is x, 1 less power. Keep the constant out. Power, base, 1 less power. What's the derivative of a constant by itself? 0. So anyway, I get the derivative to be 3x squared plus 4x. I want f prime of what? I believe I was finding f prime of negative 2. So what does this become? 12 minus 8 or 4. Okay, I was also asked 5, which is this one. If you know what the square root of x looks like, the absolute value is only there so you take square roots of positives, which is all you can take anyway. This is the square root of x. I can draw a tangent line most places. I can draw a tangent line here. I can draw a tangent line here. But if I don't have anything to the left or right, I really can't draw a tangent line at 0. So this is said to be non-differentiable at x equals 0. If you were to actually take this derivative, square roots of 1/2 power, power base 1 less power, there's your 1/2, that means the square root is on the bottom. There's the derivative, or g prime of x. Now, can you put a 0 into that? No, it's non-differentiable at 0.